So if you're listening to these in order, printing out the slides, you'll notice that I took one slide and I bumped it later, and I hope that's okay with you. I just wanted to spend just a minute talking about this idea of a capping inversion, where, again, we're talking about this sort of kind of a single cell-ish air mass thunderstorm, and this is one scenario where it can happen. These would be your afternoon storms that develop kind of suddenly, and here's why. Basically, let me kind of get my pointer up here. Like this slide says, you end up with kind of a nice whole layer of relatively cold and dry air. And one of the things we know about cold air is it doesn't want to rise, and dry air, it doesn't want to rise. So this is a very stable layer of air. Now, to me, that's important. Relatively large body of air that's going to act as a cap, a lid, kind of like when you have on your stove. And so underneath then that lid, we have warm, moist air. And again, it's a whole layer. Now, one of the things we know about warm air is it tends to want to rise, and we know about moist air is it tends to be unstable too. So here, this is the cap up here. And notice this is the first slide of 3 to kind of show you the development of basically this unstable air is basically going to blow the lid through that capping inversion. So a little bit later then, you can kind of see down here at the surface, remember this is like a clear sunny day when it started out. So basically we have, this is going to heat up down here. Now it's interesting that in this figure actually we're showing the potential for the urban island heat effect. Okay, so but it's not, doesn't have to be a city where you get these capping inversions, I don't think. So basically we still have stable air, that kind of light blue here, we still have stable air, and this is becoming more and more unstable. I guess I should kind of point down to here. It's becoming warm and I don't know, not necessarily more moisture coming in, but it already was high. It was kind of humid anyway. And then at some point, basically, that chunk of air that was down here, okay, it gets more and more unstable, and at some point, basically, it blows the lid off of that capping inversion. So it's kind of a sudden sort of development. Now, if I were to ask you which of the 3 stages is this thunderstorm cell, and hopefully you would say it's in its cumulus stage. Why? Because it's all updraft, no downdraft. But this is potential now to go ahead and develop vertically and go ahead and the collision coalescence process to continue within the cloud and get some precipitation, get some friction going on within the system, and you can get some lightning and that sort of thing. So this is generally called what we call a capping inversion.